Good morning, everyone. My name is Vishwas. Today, I'm here along with a new video regarding some important questions, or we can call it as HOTS, high order thinking skills, that can come in your CBSE syllabus, and it's important from the CBSE point of view. So, kindly pay attention towards these questions and try to do that, right? So, first question is list four properties of the image formed by a plane mirror. Properties of image formed by a plane mirror are: it is always virtual and direct, its size is equal to the size of the object, it is formed by at the same distance behind the mirror as the object in front of the mirror, it is laterally inverted. So basically ये imaginary image होती है because ये कहाँ बनती है, image के पीछे बनती है, right? So erect मतलब राइट लेफ्ट लगता है और लेफ्ट आपका राइट लगता है, दैट इज इरेक्ट. एंड इट्स साइज इज इक्वल टू दैट ऑफ द ऑब्जेक्ट, मतलब जितना आपका साइज है मिरर के सामने उतना ही आपकी इमेज का साइज होगा. जैसे जैसे आप क्लोज जाएंगे इमेज का साइज बड़ा होता जाएगा, राइट? बिकॉज आपका साइज भी क्या हो रहा है, बढ़ रहा है जैसे जैसे आप पास आ रहे हैं, राइट? नेक्स्ट इज इट इज फाउंड एट द सेम डिस्टेंस. जितने डिस्टेंस पे आप खड़े हैं मिरर से उतने ही डिस्टेंस पे आपको इमेज फॉर्म होती हुई लगेगी मिरर के अंदर, राइट? इट इज लेटरली इन्वर्टेड. लेटरली इन्वर्टेड मतलब राइट लेफ्ट लेफ्ट राइट, राइट? नेक्स्ट इज list four properties of the image formed by convex mirror. Now, convex mirror properties are: number one, it is always formed behind the mirror, between the pole and the focus. It is always virtual and direct. Its size is always smaller than the object. Magnification is always positive. So there are four properties again. So it in this case, in case of convex mirror, image is formed behind the mirror, between the pole and focus if the object is kept, right? And it is always virtual and direct, हमेशा virtual और direct image बनेगी. And imaginary मतलब, right? Its size is always smaller than the object. अब इसका जो size है हमेशा क्या होगा, छोटा होगा object के size से. Next, magnification is always positive, so m in this case will be always positive, not negative, right? छोटा होगा, less than 1 हो सकता है but greater than 0 होगा, right? List four properties of the image formed by a concave mirror when object is between focus and pole of the mirror. So in this case, what happens is the image is formed behind the mirror, right? Image mirror के पीछे ही बनेगी. It is enlarged and magnified, highly magnified. It is virtual. It is erect. So these are basic points that we have already discussed earlier also. Now this is a quite important question that have came in the board 2 years back. So redraw the ray diagram and show the path of the refracted ray. अगर मैंने आपको बताया था according to the rule of the lenses and mirror, अगर कोई भी ऑप्टिकल सेंटर या पोल से इमेज पास करती है, so what will happen? पोल से पास करेगी तो वो रिफ्रैक्ट हो जाएगी, बट अगर ऑप्टिकल सेंटर या सेंटर ऑफ कर्वेचर से पास करेगी then it will go straight without any kind of bending or deviation, right? So this is the optical center and this is the ray of light, so it will go straight without any kind of deflection. In case of lenses, in case of mirrors, if we will they will tell you, if we will strike the pole over here then it will form the same angle. If it will go through the center of curvature then the angle will not be changed, it will go straight and bounce back. Now see this, redraw the ray diagram. In this way, they can give you a question in which a ray of light is passing through the focus f1 in case of a convex lens, and from where it will go, what kind of image will be formed over there, how the ray will go after refraction. See this, as it is passing through the focus, so I have told you it will become parallel to the principal axis after refraction from the mirror. So it is becoming parallel to the principal axis and the image in this case will be found at infinity. Now this is next question. Now in this case, as you can see, I have told you outer तरफ shading है, right? So ये कौन सा केस है, कौन से मिरर का केस है, कॉनकेव मिरर, दो शैतान बच्चे, राइट? सो सी और एफ के बीच में अगर पड़ा हुआ है आपका ऑब्जेक्ट, सो वेयर विल बी द इमेज फॉर्म? Just remember that C और F के बीच में पड़ा हुआ है. One ray will go parallel to the principal axis, strikes the mirror and passes through the focus and go straight. The other ray will strike the pole. After getting reflected from the pole, it will again go straight, where both the rays will meet beyond the center of curvature. At that point, the image will be formed, that is represented by A dash and B dash, right? Okay, and you can observe in this case the height of image is more than the height of object, that is image is magnified and virtual and indirect, right? Is it virtual and indirect? No, real and inverted, right? Now pay attention towards all these things, whatever I am explaining to you. Which kind of mirrors are used in headlights of a motor car and why? Concave mirror to get the parallel beam of light. मोटर कार्स में हम लोग कौन से मिरर्स यूज करते हैं? कॉनकेव मिरर, ताकि क्या हो, पैरेलल बीम ऑफ लाइट रहे और इन ऑर्डर टू हैव अ वाइडर फील्ड ऑफ व्यू आल्सो, राइट? हमें ज़्यादा लाइट स्प्रेड करनी पड़ती है सो दैट हमें आगे जो ऑब्जेक्ट्स आ रहे हैं उनको क्लियरली विजिबल या देखने में परेशानी ना हो, राइट? नेक्स्ट इज एक्सप्लेन विद द हेल्प ऑफ अ रे डायग्राम व्हाई अ pencil partly immersed in water appears to be bent at the water surface. Now, this is a pencil which is partly immersed in water, but it seems to be like little bit up from the surface. Why? Because of the refraction of the mirror, right? Lens, sorry. Or you can say there is no lens, no mirror. The refractive index of the medium also you can say. So basically refraction is going on from denser and this is a rarer medium. So light will bend away from the normal when it goes from denser to rarer medium. So in this case, that's why the pencil appears to be little bit raised, as we are going to see these are the two rays. First one is this and the second one is this. So the two rays after going from denser to rarer medium, they are bending away from the normal. Right? This is away from the normal and this is towards the normal. So when it is away from the normal, we are going to extend that rays at the back. Then it seems to be appear little bit raised up, right? Okay. Now next question is name the type name the type of mirror used in the following situations. I have already explained you in the previous videos. Headlights of the car. Concave mirror is used because light from the bulb placed at the focus of it gets reflected and produces a powerful parallel beam of light in order to have a parallel beam of light, right? So concave mirror हमेशा हम यूज करेंगे ताकि parallel beam of light रहे. Rear view mirror of vehicles, convex mirrors, right? In order to have a wider field of view because बड़े ऑब्जेक्ट्स होते हैं उनका एक छोटी सी जगह पे आपको इमेज बनाना होता है, right? In order to form that image, we have to use convex mirror in order to have a wider field of view on a small area. Then solar furnace, support your answer with reason. Solar furnace concave mirrors. Concave mirror has the property to concentrate the light coming from sun. So basically what happens in case of concave mirror, its property is to concentrate all the sunlight over a particular point that is known as focus. So that's why we are going to use this in order to have a increase in temperature in case of our solar focus. Next is a concave lens has focal length of 20 cm. At what distance from the lens a 5 cm tall object should be placed so that it forms an image 15 cm from the lens? This is image distance, this is focal length, and this is height of object. So they are giving you height of object, image distance and focal length. First of all, you have to find out u. So u will come in minus, as the formula will be 1 by u is equal to 1 by v minus 1 by f. That's the basically lens formula because we are talking about lens in question. And In this case, what you have done is when you have put it down the values, this minus and this minus has become plus. Now, after taking the LCM, you will get u as minus 60 centimeter, and m is equal to height of image upon height of object, which will be equal to v by u. In this case, we are not having any minus sign, because in case of magnification of lenses, we are having a positive sign over here. So hi is equal to v upon u into h naught. अब हमें निकालना था h height of image, तो h naught या height of object यहाँ पे ऊपर आके multiply होगा, and you will get a term like this. And after getting solve this term or dividing this term, you will get 5 by 4, which is equal to 1.25 centimeter. That means height of object was 5 centimeter and height of image is 1.25 centimeter. That means image is diminished and virtual, right? Now, an object 50 centimeter tall is placed on the principal axis of a convex lens. Its 20 centimeter tall image is formed on a screen placed at a distance of 10 centimeter from the lens. Calculate the focal length of the lens. So, height of object is 50 centimeter, height of image is 20 centimeter, and B is 10 according to the question. So, what we are going to do is we are going to calculate the value of m by the same formula of lenses. So, height of image upon height of object is equal to image distance upon object distance. According to the sign conventions, we are getting the value of u as minus 25 centimeter, as we have already done in the previous question, and the formula will be for finding out the focal length is 1 by f is equal to 1 by v minus 1 by u. 1 by 10 minus 1 upon minus 25, you will get this as plus minus minus plus. So 25 plus 10 upon 250, that is 250 upon 35. Why this reciprocal is there? Because 1 by f was there and here we have done f. So which is equal to 7.14 centimeter. Kindly try it yourself in order to have a better understanding of all these questions. These are quite really very important. So draw the ray diagram in each case to show the position, nature and image form when the object is placed. So I will prefer you to pause the video over here and just try it yourself once in order to see how much you have learned till now, right? I'm explaining the things over here, but I'm saying you to pause the video and try it yourself once. So at the center of the curvature of a concave mirror. So when the object is placed at the center of curvature of the concave mirror, so real inverted and same size image will be found at the center of curvature only. So this will be the figure as I have already explained in the notes and while giving a brief explanation related to the chapter. Between the pole and focus of a concave mirror. Now this is between the pole and focus. So this is focus, this is pole. The over here, the rays will go parallel to the principal axis and will extend like this, and that the same ray will pass to the focus, and after that we are extending this ray at the back side of the mirror. The another ray will strike the pole of the mirror and it will go like this. Angle I will be equal to angle R in this case, and we are going to extend this ray as well at the back side of the mirror. So we are going to obtain A dash B dash. So third case was in front of a convex mirror. तो front मतलब हम कहीं भी रख सकते हैं. So one ray will go parallel to the principal axis, the other will go to the pole, and the image will form over here, right? Okay. Next case is add 2f of a convex lens. Now it's a case of a lens, and let's see what happens in this case. At 2f means center of curvature only, so image will form at 2f and on the other side of the lens. So this will be a kind of real inverted and of the same size as that of the object, because 2f means the center of curvature only in case of lens in front of a concave lens. So let's see. In front of a concave lens, this is a concave lens, and in front the object is kept over here. One ray is going parallel to the principal axis. It will diverge like this because this is also called as diverging lens, and when we are going to extend that ray backward, it will pass through the focus, because the rays parallel to the principal axis always pass through the focus of the mirror, and the other ray will go like this, passing through the optical center, and it will go straight. So the object will be on the image of the object will be formed over here, where both the rays intersect each other. That is between pole, or you can say optical center, and the focus, right? So this is the object. You can see the object size is less than the image. Oh, sorry, image size is less than the object size. So you can say the image formed is diminished and virtual and direct, right? Okay. No, not we are not over with the topic. There are many more to come. So as you can see, we are on page number 58 right now, and we have to do till 90. So a lot more to go. This is a quite lengthy chapter, and there can be a number of questions that can be there from this chapter. If a light ray IM is incident on the surface AB as shown, identify the correct emerging. So this is the kind of figure that the teachers can give you, and this can be little bit changed as well according to their convenience. So what they are asking is identify the correct emergent. तो emerge कैसे करेगी रे? इमर्जेंट रे आपकी यहाँ कहीं होती है, राइट? सो पी क्यू आर कौन सी आपकी इमर्जेंट रे है, राइट? पैरेलल टू द ओ एस. सो आई थिंक इट्स एन क्यू, बिकॉज ये तो आपकी बिना बेंड हुए जा रही है, तो बेंड होना जरूरी है. सो दिस विल बी एन क्यू. इतना ज्यादा बेंड भी नहीं होगा एन आर की तरह. सो इट विल बी एन क्यू, right? So you have to understand the figure, and you have to apply the concepts that you have learned. Now, draw ray diagrams to represent the nature, position, and relative size of the image formed by a convex lens for the object placed at. First part is at 2f1, that is here, right? So when the object is placed at 2f1, the image will form at 2f2, right? So in this case, what will happen? The object is placed over here, ray go parallel to the principal axis, meet at focus, meet at center of, passes through the center of focus, and meet at 2f1, because the other ray which is coming from and passing through the optical center of the mirror, intersecting the other ray at 2f1, right, which have already been obtained after passing through the focus. So real inverted and of the same size as that of the object is the nature of the image, and position is at 2f2. Now between f1 and the optical center. Now object is placed between f1 and the optical center, that is this is the object. One ray go parallel to the principal axis, passes through the focus, and the other ray passes through the optical center and go straight. So when we are going to extend these rays at the back side, front side of the mirror only, the length only, then what will happen? So we are going to obtain an image, virtual image like this, A dash B dash. As you can see, it's a quite enlarged image, and position will be on the same side of the lens. Next is a ray of light incident obliquely on a face of a rectangular glass slab placed in air emerges from the opposite face parallel to the incident ray. State two factors on which the lateral displacement of the emergent ray depends. So, two factors are basically lateral displacement depends upon the angle of incidence and thickness of the glass slab and the refractive index of the material. You can write any two if they have asked you to. First one is angle of incidence. That second one is thickness of the glass slab or the refractive index also. Right. Now next is again a numerical. An object 2 cm in size is placed 30 cm in front of a concave mirror of focal length 15 cm. At what distance from the mirror should a screen be placed in order to obtain a sharp image? What will be the nature and the size of the image formed? Draw a ray diagram to show the formation in this case. So let's understand the question first of all. The object 2 cm in size, that is, this is the height of the object, placed 30 cm in front of the concave mirror. So concave mirror है तो focal length तो negative हो गया, that is -15, and this is the value of u, that is object distance, that is also in minus. So when you are going to place the values in this formula, 1 by f is equal to 1 by v plus 1 by u, you will get the value of v as minus 30 centimeter. That is वो भी same side पे है, right, as that of the object. So डिस्टेंस अगर आप देख पा रहे हो तो इसका भी 30 है और u का भी 30 है. दैट मीन्स वो इमेज का पड़ी है सेंटर ऑफ कर्वेचर पे, राइट. So in this way we have to find out where the image is kept by looking at the distance between the image and the object from the pole of the mirror. That is, we have to calculate the value of v and u, and according to that, we have to find the ray diagram which is the best suitable for this. Next is, and I've written this line at last. In the question only, after reading the first line, I came to know that this will be the answer. How come? Because if you can see over here, यहाँ पे focal length मैंने 15 दे रहा है और object मैं 30 दे रहा हूँ. तो आपको पता होना चाहिए, मैंने आपको बताया था focal length is half of the center of curvature, right? Right? So focus कहाँ है? Focus basically half point पे. So half point पे होने का मतलब, you know, सेंटर ऑफ कर्वेचर 30 है और ये 15 है, राइट. सो ऑब्जेक्ट कहाँ पड़ा हुआ है? सेंटर ऑफ कर्वेचर. नेक्स्ट इज, एन ऑब्जेक्ट 2 centimeter high is placed at a distance of 64 centimeter from a white screen. On placing a convex lens at a distance of 32 centimeter from the object, it is found that a distinct image of the object is formed on the screen. What is the focal length of the convex lens and size of the image formed on the screen? Draw a ray diagram to show the formation of the image in this position of the respect with respect to the lens. So अब वो क्या कह रहे हैं? डबल ऑफ दैट ऑफ द फोकल लेंथ से डबल. सो ऑब्जेक्ट 2 सेंटीमीटर है, ऑब्जेक्ट का साइज 2 सेंटीमीटर दे रहा है एंड डिस्टेंस 64 सेंटीमीटर फ्रॉम द वाइट स्क्रीन. On placing a convex lens at a distance of 32 centimeter from the object, it is found that distinct image will be formed. 32 सेंटीमीटर पे हम रख रहे हैं तो फोकल लेंथ उसकी क्या है? 16, राइट. सो फोकल लेंथ 16 है, 32 पे ऑब्जेक्ट पड़ा है. अगेन यू केम टू नो दैट 2f पे ऑब्जेक्ट पड़ा बिकॉज ये डबल डिस्टेंस है, राइट. सो 16 और 32 से मेरे को पता लग गया दिस विल बी द फिगर ऑफ द क्वेश्चन, राइट. Next one is, why does a ray of light bend when it travels from one medium to another? Due to a change in velocity in the medium, due to reduce the time taken to travel the same. So basically क्या होता है, जब आप रेयरर से डेंसर मीडियम में या डेंसर टू रेयरर मीडियम में ट्रैवल कर रहे होते हैं, इट्स समथिंग लाइक आप एक ट्रैफिक वाले एरिया में गाड़ी चला रहे हैं एंड विदाउट ट्रैफिक एरिया में गाड़ी चला रहे हैं. तो यू कैन सी यू योर स्पीड एंड यू कैन जस्ट इमेजिन आपकी स्पीड कहाँ ज़्यादा होगी या वेलोसिटी कहाँ ज़्यादा होगी, राइट. ऑब्वियसली इन अ नॉन ट्रैफिक एरिया जहाँ पे आप इजीली अपना स्पीड इंक्रीज कर सकते हैं. सो दैट्स व्हाई लाइट यूजुअली बेंड्स टू रिड्यूस द टाइम टेकन. आपको अगर टाइम रिड्यूस करना है, सेम वेलोसिटी रखनी है, तो आपको क्या करना पड़ता है? ट्रैफिक वाले एरिया में आपको इधर उधर से निकलना पड़ता है बेंड होके. सिमिलर केस द लाइट विल डू इन दिस, राइट. ओके. नेक्स्ट इज, redraw the ray diagram given below in your answer book and show the direction. So this is again very easy. So it will go like this and will pass through the focus, as you can see. So it will be parallel to the principal axis, right, in this way. Next, a convex lens has a focal length of 10 centimeter. At what distance from the lens should the object be placed so that it forms a real and inverted image 20 centimeter away from the lens? What would be the size of the image formed if the object is 2 centimeter high? With the help of a ray diagram, show the formation of the image by the lens in this case. So f is equal to 10 centimeter, v is equal to 20 centimeter as explained in the question. Focal length they are given you 10. It will be plus 10 only because convex lens is there, and height of the object they have given you 2 centimeters. So lens formula you have to apply over here. 1 by f is equal to 1 by v minus 1 by u. So 1 by u come out to be 1 by v minus 1 by f, right? So in this case, after doing the calculation work, you will get u is equal to minus 20 centimeter, which will be equal to twice of focal length, right? So after judging this, it is twice of focal length. Again, that same figure will be drawn over here, right? In this case, you just label the object as AB and the image as A dash B dash. Now see this. This is a refractive index kind of question. So refractive index of water is this. Air is this. So formula will be n is equal to speed of light in air or vacuum or upon speed of light in given medium. So C upon V. So C is 3 into 10 raised power 8 meter per second, and refractive index is 1.33. So 1.33 you will put it here, and you will get the value of V, right? So that's 2.25 into 10 raised power 8 meter per second. Next is the refractive index of glass is 1.50 and the refractive index of air is 3 into 10 raised power 8 meter per second. Calculate the speed of light in glass. So refractive index is equal to n, that is equal to C upon V, and V you have to find out the same formula you have to apply. 3 into 10 raised power 8 upon 1.50, that will come out to be 2 into 10 raised power 8 meter per second. Understood? Try it on your own. For which position of the object does a convex lens form a virtual and erect image? Explain with the help of a ray diagram. When the object is placed between the focus and the optical center, a virtual and erect image will be formed. So this is the case of that. So you can see the object is placed between F and O, uh, and the ray which is going parallel to the principal axis will pass through the focus, and uh, the other ray passes through the optical center of the lens. When both these rays are extended at the same side of the mirror, so lens, then what will happen? Ray appears to be intersecting at this point, and A dash B dash shows the height of the image which is getting formed over here. This is a kind of virtual image. Next is, in an experiment with a rectangular glass slab, a student observed that a ray of light incident at an angle of 55 degrees with the normal on one face of the slab. After interaction, strikes the other face of the slab before emerging out into the air, making an angle of 40 degrees with the normal. Draw a label diagram to show the path of the ray. So you can see this. This is the label diagram, right? So this experiment might be have done earlier in school. So rays going like this, making an angle I that is 55 degree with the normal, and bending this at angle R1 and forming angle R2 with this normal ray, and it is coming out to be 40 degree over here. That is angle of emergence, right? Okay. So this is 55. This is 40. This is the written explanation part over here. R2 is 40, R1, R2 will be 40, right? Angle I and E will be 55. So these two are the angles which we are talking about. This is with the normal, right? This angle will be with the normal, and this emergent angle will be 55, and this I will also be 55. And these two angles will be always same, right? At what distance should an object be placed from a convex lens of focal length 18 cm to obtain an image at 24 cm from it on the other side? What will be the magnification produced in this case? F is equal to 18 cm, right? According to the question, V is equal to 24. So you have to calculate the value of U. That comes out to be minus 72 after using the lens formula, that is 1 by f is equal to 1 by v minus 1 by u. I hope you know how to take the LCM. So you have to find the magnification. M is equal to v by u, that is 24 upon minus 92, that is minus 1 by 3. From here you will get the value of m will be less than 1. So what will you get as image is inverted, real, and of the smaller size as that of the object, that we call as diminished, right? What is the nature of the image formed by a concave mirror if the magnification produced by the mirror is plus 3? So positive sign of the magnification indicates that the image is virtual, erect, and enlarged. So virtual है, erect और बड़ी image है, right? So between 2 points of concave mirror should an object be placed to obtain magnification minus 3. So minus कब आएगा? Negative sign indicates that image is real and inverted. So size of image is also enlarged. So object must be positioned between f and 2f. That's the case, right? So define and show on a diagram the terms relating to a concave mirror, aperture, radius of curvature. So this is aperture, the refracting surface of the mirror is known as basically aperture, or the diameter of the refracting surface you can say. And radius of curvature is uh, cent- the distance between the center of curvature and the pole of the mirror, that is known as radius of curvature. Next is, how far should an object be placed from a convex lens of focal length 20 cm to obtain its image at a distance of 30 cm from the lens? What will be the height of the image if the object is 6 cm tall? So f is equal to 20 centimeter and v is equal to 30 centimeter according to the question. So we have to find the value of u, that is by the lens formula obviously. 1 by f is equal to 1 by v minus 1 by u. The value of u comes out to be minus 60 centimeter, and we have to find out the height of the image. In order to get the height of the image, we have to use this formula. So hi is equal to v upon u into h naught. That comes out to be minus 3 centimeter. Negative sign shows that the image is real and inverted, right? Okay. So today we are going to do 30 questions only, right? So next we will do it in our next video. The image of the object placed at 60 cm in front of a lens is obtained on a screen at a distance of 120 cm from it. Find the focal length of the lens. What would be the height of the image if the object is 5 cm high? So image of the object placed at 60 cm, that is u they are giving you, and object placed, right? Just focus on this. Don't take it like image पड़ी हुई है. ये object पड़ा हुआ है 60 centimeter पे, right? Distance of 120 centimeter from it. So v 120 है और u minus 60 है. That is आपको focal length निकालना है. Focal length comes out to be 40 centimeter, and at last they have asked you height of image. So that is h naught into v upon u according to this formula of magnification. So it comes out to be 10 centimeter. So I hope you have understood this video and you will try all these questions at your home. At the end, I just want to say that be safe, stay at your home and help your parents and study as well. Thank you and have a nice day.